Students, welcome to Trimal classes. So today in this class, we are going to learn about the first important topic in arithmetic, that is number system. Number system is a very important topic. So almost all you write any exam, it has it has a weightage of 20% of questions from the arithmetic. So you can understand how important this topic is, number system. If you learn the number system thoroughly, even it is useful for the remaining topics also. So that's why you need to pay a lot of attention on this topic. So in this topic, we are going to learn from the scratch to zenith. So we learn all the things in the number system. Okay. So before I start the number system, different problems, different methods. So first we'll start our number system concept from basic definitions. So definitions are not important to by heart. I mean, you don't need to by heart the definitions, but so the expressions, the concept behind the definitions are very important. Okay. So what is number actually? So first we'll talk about the digits. We'll talk about the digits. So digits means that any digit from 0 to 9 are called, anything from 0 to 9 are called digits. So if you say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all these are called digits. The combination of digits is called number. Okay, if you take one digit, if you take another digit, if I combine them, this is called a number. This is called what? A number. Simply if I say that 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 individually, all these are called what? Digits. Okay. So we have different types of numbers. Numbers means that what? Numbers is nothing but a combination of numbers or nothing but combination of what? Digits. Okay. By the way, we had different kinds of numbers in the number system. Okay. So actually we have a term called number line. And we also talk about this number line. Number line is nothing but, so if you represent any number on a line, that is called number line. Okay, starting from 0, all the numbers which comes in the right side part are positive numbers. All the numbers which comes in the left side part are called negative numbers. Okay, so we have these positive numbers and we have the negative numbers. So you can write the numbers as 1, 2, 3 and so on up to infinity. Okay, so this part is -1, -2, -3, -4 up to minus infinity. Okay, a number line is nothing but on a line, if you represent the different numbers, so that line is called number line. Okay, so here only these, not just only these numbers, we can also represent the numbers like 0.5 or 0.3, which means that decimal numbers, or 1 and 1/2, which means that fractions. So likewise you can represent anything. You can represent anything on a number line. You can represent any number on a number line. Number line is nothing but if you represent the different numbers on a line, that is called number line. Okay. And now we'll see what are the different types of numbers we have in the complete number system. Okay, suppose if you see this one, so numbers means that of course we have many numbers. Out of them the most important are, so generally numbers are classified into real numbers and imaginary numbers. The first thing is what? The first classification is real numbers and imaginary numbers, and these real numbers are classified into rational and irrational. These rational numbers are divided into fractions and integers. Of course in the fractions again we have proper fractions, improper fractions and mixed fractions, and integers again it is divided into natural numbers, whole numbers, and then even numbers, odd numbers, prime numbers. All this such kind of different numbers we are going to learn it in this class. Okay, so the first basic classification of numbers is, it is divided into real numbers and imaginary numbers. Okay, first we talk about the real numbers and imaginary numbers. What are these real numbers and imaginary numbers? As the name suggests, real number and imaginary numbers. Real numbers means that actually those numbers are existed in the universe. Imaginary numbers means that you are just imagining those numbers which are actually not there in the numbers line. only we are representing, only we are imagining those numbers for our calculation purpose. For this higher mathematical calculation purpose, we imagine some numbers. Those numbers are called imaginary numbers. Generally, these numbers are represented by I. Okay, maybe so you have been studied like 4 plus 3i numbers, such kind of numbers. Actually, these numbers are called complex numbers. Anyway, these imaginary numbers are not necessary for us. Okay, so whatever the syllabus we have, so in our syllabus we deal with only real numbers. We don't have the part of imaginary part. Okay, so that's why we don't talk about here, so about the imaginary numbers. Only we talk about the real numbers. Okay, now we'll discuss about what are the different types of real numbers we have. Suppose if you take that, what is a real number? What is a real number? Okay, the first kind of numbers is what? The first kind of numbers are real numbers. Real numbers means that the numbers which exist on the number line are called real numbers. The numbers which exist on the number line are called real numbers, which means that you know that what is number line means that. Number line means that you draw 0 and all the numbers on the right side part is positive numbers and all the numbers in the right left side part is what? Negative number. As I mentioned already, so you can represent fraction or you can represent any number here. You can represent a decimal number. See, I represent 1, 2 like integers, and I can also represent, let's say that 1.5. I can also represent some 1 by 2. I can also represent root 2 value. Root 2 value is what? 0.3010. So, sorry, 1.414. So, you can represent like anything. So, 1 can be somewhere like 1.414 like that. So, root 2 can be represented here. So, like whatever the number you assume, okay, all the numbers if you can represent on the number line, so those numbers are real numbers. In other words, I'll put it in the simple words, that is nothing but what? Real numbers are nothing but, so whatever the number you can take, all the numbers are real numbers only. Because all those numbers are existed on the number line. Okay. So, number line means that you can represent any number there. So, you can represent the root, cube root, fourth root, or you can represent the decimal numbers, or you can represent the fractions, or likewise you can represent any number on the number line. So, that's why we call them as real numbers. Okay. And when we talk about the number line and also positive numbers and negative numbers, we have two terms, non-positive integers or non-positive numbers and non-negative numbers. Anyway, we'll see it later. So, first of all, just remember that real numbers means that you can take any number that could be belongs to real number, because all the numbers we can represent on the number line. Okay. So, what is the next number we have? In the real numbers, what are the different numbers we have? The first kind of numbers are rational numbers. In the real numbers, part, in the real numbers, we have the first one. What is the first one? Rational numbers. Rational numbers. What are rational numbers? Rational number means that if any value or any number which can be written in the form of p by q, those numbers are called rational numbers. Okay, if any number can be written in the form of p by q and also where q not equal to 0, those numbers are called rational numbers. See, any value or any number that can be written in the form of p by q. Okay, simply it is what? Simply it is nothing but p by q. Any number which can be written in the form of p by q. All such numbers are called what? All such numbers are rational numbers. Okay. So, and we have also a condition that where q not equal to 0. Q means that what? Q is a denominator part. So, if you write any number in the form of p by q and also q not equal to 0, this part not equal to 0, such kind of numbers are rational numbers. So, then what are the examples for the rational numbers? So, any number which can be written in the form of p by q means that it's like a fraction, right? Okay, p by q, which means that for a fraction, so we have a numerator term and we have a denominator term. So, those numbers are nothing but rational numbers. Suppose if I take the example 4 by 3, can I call it as a rational number? Yes, you can call it. So, because it is in the form of p by q and also q means that the denominator part is not equal to 0. So, we write the number p by q in the form of p by q and also the denominator part is what? Not equal to 0. So not just positive numbers, you can also take the negative numbers also. Even I would say that minus 2 by 3, which is in the form of P by Q. So this represents P and this represents Q. So I can say that minus 2 by 3 is also an example of what? Rational number. Okay. And suppose if I take number 4. Let's take the number 4. I'll take the number 4. Can I say 4 is a rational number? Yes, of course, 4 is a rational number. See, here the definition is any value that can be written in the form of P by Q. Okay. Here suppose if I give 4, can I write 4 as 4 by 1? Yes, you can write 4 or 4 by 1, both are same, right? So you can write this number 4 as 4 by 1. So I write the number in the form of what? P by Q. If you can write any number in the form of P by Q, so those numbers are called rational numbers. So I can say that 4 is a rational number. And what else? What else the numbers we have? So suppose if I take the 0.5, can I say that 0.5 is a rational number? Absolutely, because 0.5 is represented as what? 5 by 10. So which means that all decimal numbers are also rational numbers. If I give you any decimal number, suppose if I give you that 1.25, you can write this number as what? 125 by 100. Isn't it? 125, first you write the complete number divided by 100. First we write 1 and after that how many, after decimal point how many digits we have? 2 digits. That means that we simply put 2 zeros. So even I can say that any decimal number belongs to what? A rational number. Apart from these numbers, there is another point you also remember that all recurring and terminating decimals are rational numbers. All recurring and terminating decimals are rational numbers, which means that what is meant by recurring numbers? Recurring numbers means that suppose if you take recurring numbers, so recurring numbers means that maybe you could see the numbers like this, right? 0.4 bar or something 1.215 bar or something 16.15 bar. Can you see these kind of numbers before? Yes, obviously we have learned it in our 10th class or 9th class, right? Okay, so what it means that 0.4 bar means that 0.4 bar is nothing but 0.444. Bar means that after decimal point if you have bar on any number, which means that that particular digit is repeating endlessly. So 0.4 bar, which is nothing but 0.444444. Okay, and so on. And suppose if I take 1.215 means that the bar is on 215, which means that you can write the number 1.215, 215, 215 and so on. 16.15 means that the bar is on which digit? 16 point. After decimal point we have the bar on 15, so which means that we can write as 151515. So these are called recurring numbers, so which means that reoccurring. Okay, recurring means that reoccurring, which means that after decimal point some particular digits are repeating endlessly. So these are also called rational numbers. Why these are called rational numbers? Because, so there is a purpose, because all these numbers can be written in the form of P by Q. All these numbers can be written in the form of P by Q. Suppose if I have the 0.4 bar, I can write this number as 4 by 9. Okay, and similarly you can write for all the numbers. So that is a separate case. We have a separate topic on converting decimal number, recurring numbers into P by Q. So this is a separate topic. So we'll discuss about these things, how do we convert into P by Q in the coming classes. But as of now, you remember that any bar numbers are belonging to rational number. Any bar numbers belongs to what? Rational number. That point you remember. Okay. Now, okay, so this is about the rational number. So rational number means that what? Any number which can be written in the form of P by Q, where Q not equal to 0. We have the examples at what? P by Q. So this is PQ, minus 2 by 3. Example, positive numbers, negative numbers. Even if I give you that simple number 4, so we can write as 4 by 1. So that's why we can say that even integers also what? So normal rational numbers. And 0.5 means that what? It is a decimal number, or 1.25. So all decimal numbers are rational numbers. And also recurring numbers. Recurring numbers means that I can say that 2.35 bar. Suppose the bar, so all the bar numbers, which means that recurring numbers are also examples of what? Rational numbers. And also terminating decimals means that, so terminate means that end. Okay, so you can write any big number, 1.4316756, something like that. Okay, 1, 2, something. After decimal points there is a big number, but still after some point it ends. Then these numbers are called terminating decimal. That means that it is stopped there and you can't continue after these numbers. So such kind of numbers, that means that terminating decimals are also what? Rational numbers. Okay, so this is the concept of rational numbers. Rational number means that any number which can be written in the form of p by q, and also where q not equal to 0, those kind of numbers are called rational numbers. And also the examples are any fraction value, any integer value, any decimal values, any recurring decimals, which is nothing but bar values, are examples of rational numbers. Definitions are important because sometimes it is given like that, which of the following is a rational number, which of the following is a irrational number. So you have such kind of questions. So, and also apart from knowing the definitions, so these definitions are very important while doing different problems. Okay, so you can understand the importance of definition while we are doing the problem. So that's why don't neglect this topic. I don't want you to by heart them, but remember the concept. Okay, so by the way, this is about the rational number. And also if you observe that I told you that, so q not equal to 0, q must not be equal to 0. Why it is q not equal to 0? So where q not equal to 0, why q not equal to 0? Because suppose if any number, if I write 2 by 0, what is the value of 2 by 0? Is 2 by 0 is not defined or undefined. Any number divided by 0 is undefined. Is what? Undefined. 0 by any number is what? 0 by any number is equal to 0. If you divide with any number with 0, any number by 0 means, see, first you take this example, 0 by 2. Suppose let's say that 0 by 2. Divide 0 by 2. 0 by 2 means that if I divide, so 2 zeros is 0, I'll get the remainder 0. So what is the remainder? So the remainder is 0. Suppose if I take the 2 by 0, 2 by 0. Okay, for which quotient I'll get remainder 0? You take any number, you take 0 into 1, 0, 2 is 0, 3 is 0, 4 is 0, 5 is 0, infinity is, still you will get 0 into anything is 0. You will never get remainder 0. That's why any number by divided by 0 is what? Undefined or not defined. Okay, any number by 0 is what? Undefined. So you have to make sure that, so q not equal to 0 to say some number is a rational number. So that's why clearly mentioned that any number which can be written in the form of p by q is called a rational number. Is it clear? So this is about rational number. Now let's see the next number. The next number is irrational number. Irrational number. What is irrational number? Irrational number means that any value that cannot be written in the form of p by q is an irrational number. Okay, any number which cannot be written in the form of p by q. So rational number means that what? Which can be, rational number means that what? Which can be written as, which can be written in the form of. Irrational number means that what? Irrational number means that which cannot be written in the form of p by q, and again q not equal to 0. So those type of numbers are called what? Irrational numbers. Okay, that's good, fine. But what are the examples for the irrational numbers? Okay, if you see the numbers, almost all every number is included in the list of rational numbers. Every number is included in the rational numbers. We have the integer numbers, we have the positive numbers, negative numbers, and also what? And also we have recurring decimals. Almost all every number is taken in the category of rational number. Then what is the irrational number example? Okay, so then irrational number, for irrational number we have another definition, that is all non-recurring decimals and non-terminating decimals or irrational numbers. Non-recurring decimals, non-recurring decimal mean that what? Non-recurring decimal means that, see, you said that recurring decimal means that 0.3 bar. Okay, so non-recurring means that, so it will never end. So for such kind of numbers are called non-recurring decimal. Non-terminating means that after decimal point the term must not ever be ended. Then what are the examples for that one? Yes, the examples are any square root which is not a perfect square. Suppose if I take that any square root of value, not a perfect square. Again, if it is a perfect square, suppose if I take that root 4, what is the value of root 4? Root 4 is plus or minus 2, which means that 2. So 2 is what? You can write 2 by 1, right? So that's why not perfect squares are perfect cubes, but any non-perfect squares or non-perfect cubes or non-perfect fourth root, non-perfect fifth roots, all these are examples for the irrational number. Okay, you can take the example root 2, because the value of root 2 is what? See, whatever we can say that root 2 value is 1.414, that is an approximate value only. If you just see it in the calci, so root 2 value is 1.41462 something. Okay, it goes on like that, it will never end. That is a non-terminating decimal. Okay, so whatever we say as root 2 as 1.414, that is only approximate value, a nearer value. After decimal point we write simply 3 digits, but it is a non-terminating decimal. So that's why root 2 is an example for the irrational number. And also you can take root 3, any square root of the number, any square root number, but it should not be what? A perfect square. Why? What happens if I take perfect square? Perfect square means that root 4 is a perfect square. Okay, root 9 is a perfect square, root 16 is a perfect square. So which means that we can write that particular number as a product of two different numbers, two similar numbers, right? So root 4 means that 2. So here root 4 value 2 means that I can write it as 2 by 1, right? I can write that value root 4 value as 2 by root 4 as 2 by 1. So that it can be in the form of what? P by Q. That's why all perfect square, perfect cubes are not rational numbers. But non-perfect squares, non-perfect cubes and non-fourth root, non-fifth root, all these numbers are what? Irrational numbers. You take this example, root 3 value, again 1.7321 something and so on. Okay. Now you tell me, can I say that root 8, is it a rational number example? As absolutely, root 8 is a rational number example, because root 8 is not a perfect square. Root 8 means that you can write this number as root 2 into root 4. Even the root 4 value is 2, root 2 value is what? Again 1.414, again it is what? Non-terminating decimal into 2, again it will give you the non-terminating decimal, right? So that's why it belongs to the category of what? Irrational number. So you remember my point. So here irrational numbers means that any perfect square, not any perfect squares, and it should not be any perfect cube. So even I can say that cube root of 9. Cube root of 9 value is not known. So cube root of 27 is what? Cube root of 27 is a perfect cube. So cube root of 27 is 3. But cube root of 9 means that only we can write 3 square, not 3 cube, right? So any perfect square, perfect cube, except perfect square and except perfect cube, which means that non-perfect squares, non-perfect cubes, non-perfect fourth root, non-perfect fifth root, all these are examples for the irrational numbers. And apart from these numbers, we also have some mathematical constant values as irrational number. Those constants are pi, epsilon, or Euler constant. So what is pi value? Okay, so pi value is 3.1416. Again, it is not an approximate, again it is not an exact value, it is an approximate value. Okay. So by the way, if you take 22 by 7, again it is an approximate value. 22 by 7 is also an approximate value. So that's why pi value is what? Pi value is an irrational number. Epsilon value is what? Epsilon or Euler's epsilon, and also Euler's constant. All these are examples for the irrational numbers. So irrational numbers are nothing but non-recurring and non-terminating decimals. Is it clear? Terminating decimals or recurring decimals are belongs to which category? Yes, rational numbers. Here you have a problem and you have a question. Okay, suppose if I ask you a question like this. And you have the option rational number, irrational number, let's say that even number, odd number. Okay, suppose a question is asked like this. This was a very important question. So because it was asked couple of times in your previous year papers. Okay, different exams, the question is asked like this: 22 by 7 is a which number? Is it a rational number, or is it a irrational number, even number, odd number? By the way, we know that it is not an even number, it is not an odd number. Now the question arises, what is the answer between these two options? Okay, see here the number is 22 by 7. You just think about it, 22 by 7. So maybe if you think that this number is a rational number, that is wrong. It is not a rational number, or sorry, irrational number. If you think that it is an irrational number, that is wrong. See, because here this value is not pi. So here pi is not given. Here simply 22 by 7 is given. So 22 by 7 means that what? 22 by 7 means that this term is p. I take p term as 22, q term as what? 7. So this number 22 by 7 is simply in terms of p by q, right? Okay. So don't think that this value is pi. I am not separately given pi. So when I mean that pi means that 3.141. It is not equal to 22 by 7. Okay, that is an approximate value. If I give you that pi is which number? Pi is a rational number. Because the value of pi is what? 3.1416. That is non-terminating decimal. Suppose if I ask you that what is 22 by 7? 22 by 7 is what? So which is nothing but a simple number, if simple fraction number which can be written in the form of p by q. So it is p and it is q, which is nothing but what? A rational number. So pi is what? An irrational number. Sorry, this is what? An irrational number. Pi is what? Irrational number, because the value of pi here is what? 3.141. Actually the original value of pi is 3.141 and up to so on. Okay, so 22 by 7 we considered because of some simple calculation purpose, especially related to the geometry. Okay, in the olden days, so a lot of problems are related to the 7 multiples, and after a lot of research it was invented that so the number is 22 by 7. So first invention was 3.141 and up to so on, and later that so it is simplified as 22 by 7. Okay, is it clear? So that's why whenever somebody asks you that pi value is something 3.141. Even though 22 by 7 is the correct one, so that is used for the purpose of calculation. So here 22 by 7 is simply a p by q number, and pi value is what? Irrational number. So when simply 22 by 7 is asked, that is a rational number. If pi value is asked, if particularly the question is for what is pi, pi is what? Which number? Irrational number. Okay. You see the difference? That is the difference. Okay. Irrational number means that what? Irrational number means that root 2, root 3, root 8, cube root down, pi and epsilon. These are irrational numbers. Irrational numbers. And suppose if 22 by 7 is clearly given, 22 by 7 is which number? Rational number. Pi value is which number? Irrational number. So I write, so 22 by 7 in the examples of the rational number. Is it clear? So this is about the concept of rational number and irrational number. Now you see the next number.